Okay, welcome to video 5 here. We're going to be talking about completing the square again. So you've already learned about how completing the square works and the steps that we can use to solve quadratic equations by completing the square. So we want to solve the following by completing the square and, if necessary, express the result in simplest radical form. So in order to do that, I need to first get everything on one side. Since this 4x squared is a negative where it is, I'm going to add that to the other side. When I do that, I end up with 0 on the left-hand side and then the 4x squared plus 24x plus 11. Now I need to complete the square, so that means that I need to keep my x variables together because those are the ones I can manipulate to turn into a square. And then what I notice is that there's 4x squared. Well, I don't want to complete the square 4 times. I just want to figure out how many to complete one square. So I'm going to divide that 4 out. And once I've done that, I have the 4 out front and I'm left with the x squared plus 6x, which I'm going to complete the square with. So I added a blank after that, and then the plus 11, but since I'm adding something to my picture here, I must also take it back away here. So how many do I need to add? Well, it might help to have the visual, so I'm going to draw this out. So I've drawn my x squared, and then I have my 6 x's, 6 group of x, that I can put on each side so that it still looks like a square. So if you'll notice, it's still an x here, and I've added 3, but that's still the same as this side, which is x plus the 3 more. But my square is not complete. How many do I need to add to complete my square? So we can think of those little ones that would fill that in. It would be 9 of them. So that means I'm going to add 9 to complete that square. Now, although I've added 9 to complete the one square, there's actually 4 of them that I should have had. So I didn't just add 9, I added 4 groups of 9, which is 36. So I need to subtract 36 over here. Okay, now that I've done that, I can now complete my square in the next step by writing the 4 times x plus 3 squared, because that's the new side of the squared, x plus 3 of them, and then minus 25. So now we can just solve like we've always solved for a variable. What's happening to x? We're adding 3, squaring it, multiplying by 4, and subtracting 25. So do the opposite in the opposite order. Add 25 to both sides. And when I do that, I get 25 equals 4 times x plus 3 squared. The next thing I need to do is divide each side by 4. I get 25 over 4 equals x plus 3 squared. And now I have to do the inverse for the squared to get rid of it. So I'm going to square root both sides. And when I do that, I get the plus minus, because remember, I can square 5 halves and get 25 over 4, but I can also square negative 5 halves and get 25 over 4. So it is a fraction, but that's okay. Then I have the x plus 3. To get x by itself, I need to subtract 3 from both sides. And when I do that, I get negative 3 plus minus 5 halves, which I can simplify. So I'm going to break this to 2 answers, which would be this x equals negative 3 plus 5 halves and x equals negative 3 minus 5 halves. And when we do that, we get our 2 answers of negative 1 half and negative 11 halves. So those are our 2 answers. We can either write them in set notation or just write as x equals. So I rewrote my answer as x equals negative 1 half and x equals negative 11 halves, which you could write as decimals if you wanted. Hopefully from this video you learned that to complete the square we need to always start with our x squared, just one of them, or r squared, whatever variable it may be, and then figure out how many need to be added to my picture on each side, half on each side, and then what we need to do to fill in the blank, which would be to multiply whatever the half was. So this was negative 3. Negative 3 times negative 3 gave us the 9 here. We will keep doing more in class. Have a good night. We'll see you tomorrow.